Hello, my name is Tushar Singh, and today we are going to learn about logistic regression. Logistic regression is used for classification where the response variable is categorical rather than numerical. The model works by predicting the probability that Y belongs to a particular category for first fitting the data to a linear regression model, which is then passed to the logistic function. The logistic function will always produce a S-shaped curve, so regardless of x, we can always obtain a sensible answer between 0 and if the probability is above a certain predetermined threshold. Example, p of yes greater than 0.5, then the model will predict yes. How to find best coefficient? Maximum likelihood. The coefficient are unlikely known and must be estimated from the training data. We can seek estimates such that the predicted probability of each observation is close to 1 if it is observed in a certain class and close to a 0. Otherwise, it is done by maximizing the likelihood function. Potential issues. Imbalance classes. Imbalance in class and training data leads to poor classifier. It can result in a lot of false positive and also lead in few training data. Solution include forcing balanced data by removing observation from the larger classes, replicate data replicate data from the smaller classes, or heavily weigh the training example toward the instance of larger classes. The more class you try, predict harder it will become for the classifier to be effective. It is possible with logistic regression, but another approach such as linear discriminant analysis may prove better, which avoids multi-class classification. Now here's the code for logistic regression written in Python language. First we import numpy for two arrays x and y, and here's the rest of the code. Now let us run this code. So here's the output of the above code. Now let us understand Poisson regression. In statistics, Poisson regression is a generalized linear model form of regression analysis used to model count data and contingency table. Position regression assumes the response variable y has a Poisson distribution and assume the logarithm of its expected value can be modeled by a linear combination of unknown parameters. A Poisson regression model is sometimes known as a log linear model, especially when used to model contingency table. Negative binomial regression is a popular generalization of Poisson regression because it loosens the highly restrictive assumptions that the variance is equal to the mean made by the Poisson model. The traditional negative binomial regression model is based on the Poisson gamma mixture distribution. This model is popular because its model the Poisson heterogeneity with a gamma distribution. Now let us look at the code of Poisson regression. Now here's the code for Poisson regression. We have used a for loop and few print statement and import random and import mathematics, and here's the output. As you can see, number of arrival in successive time unit length is this array, which means the mean of the arrival time is 5.375. Thank you, that's all for this video.